Now, let's welcome Jose Diaz, VP of Products and Services at Prime Factors. In this session, Jose will challenge us to rethink how and where to protect our sensitive data. He'll be sharing insights into how shifting our focus to securing data within applications could reduce attack points and boost the overall protection. Jose will walk us through specific architectures that make data protection simpler and more adaptable over time. By the end, we'll have a better understanding of how to manage data security in a way that's both robust and efficient. A warm welcome to Jose.
Hi, I'm Jose Diaz, and I'm here to talk a little bit about how we can actually protect data a little bit better in our environments today, particularly all the sensitive data. There's different architectures that can actually be used in order to be able to better protect data. But first, we're going to take a look at where some of those challenges are and how we can actually look at a little bit differently. Before we get started, I wanted to talk a little bit about what are the topics that we're going to be covering today. First, we're going to talk about the threat landscape, because we're going to be talking about protecting data. It's important to understand what are some of the things that are happening out there and how it is impacting our decisions to secure data. Then I'm going to talk a little bit about data-centric security and what that is all about. In a nutshell, it's about making sure that we're focusing on the protection of the data itself, not so much about the perimeter or how somebody can get to the data, but protecting the data itself. We'll also talk a little bit about understanding where are some of those security gaps, or where are some of the issues that we can actually have today, and how we can actually address some of them with the slides that I'm going to be sharing. There is a little bit about security and how we can actually enhance what we call adaptive security, meaning that as things change out in the market, that we can actually keep up with some of those changes in the market. And then, wrapping it up is how we can actually protect the entire ecosystem, for sensitive data. And we'll wrap it all up a little bit after the session with some questions and answers that you may have as I have gone through the slides. So first, let's talk about the threat landscape. There was a recent report by Thales. They actually do an annual data threat report. And it was interesting that still 93% of the enterprises have seen, the threats increasing. And I think it's interesting because I think over the years, what we have always taken a look at is that those threats continue to happen. Even though we're taking certain measures in order to protect information, we're still seeing issues with what is happening with data and the compromise of data. Now, delving into that a little bit better, one of the things that we need to understand is that, security in our environments from years ago have changed considerably. It used to be that we would have a data center where everything was locked up in the data center. We protected who could actually get into that data center to make sure that the information that was sitting on those computers or those drives was secure. But things have changed over the last years, where pretty much everything having to do with an environment is spread out over a region, over the entire world. So everything is not sitting all the same place. And I think, as we all realize from a physical security perspective, it's a lot harder to be able to protect information if it is not all sitting in one place, if that information is sitting out all over the world in a sense. We also need to understand what is happening with AI, and a lot of organizations are starting to use AI in order to improve their security posture. But I think it's also important to recognize that AI is something that the hackers can actually leverage and utilize in order to be smarter about how they actually access some of the data, how they actually get into systems. There's a lot to be said for artificial intelligence, and like I mentioned, it's good for what we can do from a security perspective, but we also have to understand that it is also something that can be used from an attack perspective. And one of the other things that has a lot of press today is everything having to do with quantum computing and what is going to be the impact of it. And I think one of the things that I've seen more and was mentioned in the report from Thales in the data threat report is this concept of harvest now and decrypt later. So I can actually may not be able to decrypt the data with the technologies that are here today, but if I can actually gather some of that information, I may be able to use it later on. Now, some of the information that one can gather may only be valid for a certain amount of time. However, if we think about, for example, in the US, where we think about Social Security numbers, well, it's something that stays with us through our entire life. And therefore, if somebody can capture that information today, even if it's protected, but 5 years from now, they actually have the technology to be able to decrypt that information, then it can also be a concern. And I think that's where some of the press and everything having to do with quantum computing and the threat that it can actually present has something that we have to think about. Now, when we think about traditional data protection, as I mentioned, one of the issues is that it is a lot harder today to be able to protect the infrastructure than it was years ago. Everything is more distributed. We're trying to take advantage of what we can do in the cloud in order to not have to host servers ourselves. We want to make sure that we have resiliency, and therefore the information that we have may be in different locations, in different regions, in cloud service providers. And that, again, presents additional challenges for being able to protect information. So if we can focus and recognize it's not about necessarily where we're storing the data, but to actually focus on protecting the data itself, so no matter where it resides, that information is protected. There was also interesting information from Gartner having to do with regulatory requirements and what is happening. And I think one of the important things which I highlighted is that, when we take a look at organizations and they realize what is happening with data privacy requirements, in the different countries and in the different regions and becoming more prevalent. In addition, it's also recognized by organizations that they have to protect the data not only when it is stored, but also when it is in transit and no matter where the data resides. Now, when we think about where we have to protect data, as I mentioned, it's also important to realize that in the past, as I mentioned, it was all about let me protect the data when I have it stored. So if I put information in the database, if I put information in some sort of storage, I want to make sure that information is protected so that anyone trying to access it will not be able to do so, or if they get to access it, that information is protected. However, the challenge has been is that people, from a hacker perspective, are not attacking databases per se. They're not attacking hard drives per se. They're actually attacking and putting malware into applications in order to gather the data while it is being transited, within the systems. So even though this information from Gartner is a little bit dated, unfortunately, it is still very applicable today, as we saw with the data threat report from Thales. So the malware and the attacks that we're seeing are typically people addressing or attacking applications. It's not about being able to attack where the data is actually stored. To bring that point a little bit closer to home, when we think about data at rest, which is where we have been focusing to protect the data, it's been about how do I make sure that wherever I'm storing the data, how do I secure that hard drive or that disk or where the information is stored? Or how do I secure the data while it's sitting on a database? Or maybe I have an entire file structure that is protected and is secured and has controlled access. However, we have to realize that we're not seeing those threats that we saw from Gartner or the Thales report. We're not seeing people walking away with hard drives from an IT room or from the cloud, in a sense, or stealing databases. As I mentioned, they're actually going after the application, as was mentioned in the Gartner report. So we have to realize that when that information is actually read from those databases or read from those hard drives, that information is now available and in the clear. It is only being protected while it's being stored. That is not where the attacks are happening. The attacks are happening at the application layer, and that's the security gap that we, in a sense, have. It's not just protecting the data while I'm storing it. It's how do I secure the data so that no matter where the data resides, that information is protected. So we take a look at what happens if we are addressing data protection from an application level perspective. And as we can see here, if we decide that we want to protect the data as soon as we receive it, before we store it in a hard drive, before we store it in a database or anywhere else, or send it anywhere else, then we can actually be protected no matter where that data is residing. So it's a different philosophy of addressing how do I actually protect the data in a way that it is effective for the types of attacks that are being realized today. Now, in order to be able to figure out how we deal with modern data protection, it's about how we actually protect the data. What kind of algorithms, what kind of techniques, and we'll get into that a little bit more in subsequent slides. But it's important to realize first, how is it that we want to be able to protect the data? And then probably more importantly also is who is permitted to access that particular data. Realize that a lot of times, not everybody in the organization, not every application in an organization has the need to see all of the data or entire pieces of information. So determining what applications or what individuals can actually are permitted to see that data is also important, and also what format that data takes when the access is granted. As I mentioned, it may be, if you're dealing in the payments environment, for example, that for a payment card, they may only need to see the last 4 digits of the card. Not everyone in an organization needs to see the entire payment card number or needs to see the entire Social Security card number. We see that for a lot of times when we're asked to identify ourselves and use our Social Security number, for example, they ask for the last 4 digits. That's all that is needed in order to be able to identify oneself. And therefore, applications or programs that are actually validating that access do not need to have access to an entire Social Security number. They only need to have access to the last 4 digits for that verification. So it's important to recognize when we're thinking about data protection, it's not just about how we're protecting the data, but also how are we controlling, or how do we decide whether applications need to access all of that data or individuals need to access all of that data. Only provide the information that is needed for that particular application based on that particular use case. And more importantly, is making sure that that data is protected at the application layer the moment that that data is created, or probably in most cases today, the moment that that data is received. So if I'm working on a website and I need to authenticate myself, or I need to provide a payment card number, for example, as soon as me as a consumer or a user enters my information, my payment card number, address, whatever it is, at that point in time is when the organization should be protecting my data immediately, not waiting for that data to float around the environment in the clear. Now, what has been the challenge with actually protecting data at the application layer? Historically, when we take a look at how things were implemented previously, it was, well, I have all these crypto libraries that I can actually utilize. So we would ask a developer, let's go take a look at this crypto library and make sure that when you receive the Social Security number, you're calling this library to secure that number or that piece of data with a key. So let's go ahead and generate the key so we can use it for the encryption process. And therefore, the developer, in a sense, had to integrate these crypto libraries, how to figure out how to deal with the key management. Because if we're generating key and protecting data in one application, when I receive that information, let's say from the web, some other application that needs access to that information is also going to need that same key. So now developers are trying to figure out within an organization, not only the crypto libraries that they need to utilize to protect the data, but how are they going to handle that key management? How am I going to get the key from application A that is protecting the data to application B and C and D that need to access some of that information? And therefore, it became very complex in order for developers and organization to use these toolkits in order to be able to develop security for their applications. It was not a simple process. It took quite some time in order to implement and to maintain, if you think about key changes that may be required in order to refresh keys after some amount of time. So therefore, organizations took a look at it and said, this is really too complex to be practical. And again, that was another statement from a Gartner conference. And therefore, organizations were looking at, well, what are some of the easier approaches? And hence the reason why, well, I'll protect it at least while I'm storing it. At least I'm doing something to protect that information, because everything else was just too complex to be practical if I try to do it where I should be doing it, which was at the application layer. Now, one of the things that can be done in order to simplify the entire process is, let's say I have an application that was securing or using sensitive data and needed to be able to secure it. And you can see that I'm building within the application the ways of being able to secure that piece of information, or how to secure that data, the crypto libraries and the key management and everything that I need. So one of the ways that we can simplify application level data protection is to actually abstract everything having to do with security from the application itself. So I can build externally some method of being able to centrally manage and protect that information. So I can develop, first of all, recognize that I need to protect that data the moment that it's created, as I mentioned. And then within that policy, I can actually define how that data is going to be protected. I can define what method I'm going to use to protect that data. I can define the controls so we can access that data. And I can actually do that from a centralized perspective. Now, what that means is that it makes it a lot easier, because now applications can simply call that repository or that security engine, in a sense, excuse me, to be able to actually protect that data. It makes it a lot easier also from an integration perspective, because now developers aren't going through the issue of trying to figure out how to implement crypto libraries, how to manage keys. They can simply call some security engine in order to be able to protect that information. It's also a lot easier because you don't have to worry about trying to utilize professional services or to be able to help with some of the integration. Your developers no longer have to become crypto experts to try to figure out, what are the kind of keys that I need to utilize, or how often should I rotate the keys, what algorithm should I use. Those are things that would not have to worry about any longer if we can accomplish something along these lines. So now one of the things that we think about, I mentioned about adaptive security. And I think when we take a look at ways of being able to defining how do we actually protect that data and how to access the data, there's a few little things that we need to think about, the different mechanisms or the different technologies that can be used in order to protect that information. So first, we start out with some method of being able to protect that data, to obfuscate that data, whether it happens to be encryption, whether it happens to be tokenization. They all have different benefits or different use cases. If you're trying to secure data, encryption is a nice way to be able to do it. If you're trying to come up with an alternate value, as is typically used in the payments world to comply with PCI DSS, for example, tokenization, where I can put some value to represent that data and I can pass that token value around, is a nice, easy way to be able to protect that data, because you can usually have a little bit more control as to how those tokens are generated, how those tokens are actually utilized. So encryption and tokenization are two of the common techniques utilized in order to be able to protect information. Of course, as soon as we talk about encryption, one of the other things we have to think about is, well, I have to think about how do I manage the keys? As I mentioned, what keys am I going to use in order to protect that information? How am I going to rotate those keys if that's required? How am I going to go share those keys between different applications is something else that has to be thought about and is important as part of any kind of development that one puts together. Now, we also have to think about, data masking and redaction. Now, that's one of the pieces that I talked about. If an application is, accessing data that is sensitive, and there is a way to unsecure that data, it doesn't have to unsecure all of the data. We can unsecure only parts of that data, as I mentioned, like the last 4 digits of a social security number. So data masking and redaction are also important pieces of information or important techniques in a way of being able to protect data. Also mentioned at the beginning, all about access control. It's not just about protecting the data and masking the data for certain applications. It's also knowing what applications or what users can actually get access to that data. So access control has to be an important factor of anything having to do with data security, because if I give everybody the same access to be able to get to the data, then I may be opening up potential vulnerabilities that I didn't have to open. If a particular organization or particular group didn't have a need to see an entire social security number, why risk it and why provide that additional information? So access control is a critical part of data protection, not just securing the data, but determining who can actually access that data. And I think within a lot of the organizations and products, it's also important to be able to maintain some type of an audit log as to, right, who used or who accessed certain type of data, what departments, what applications, be able to get some reports as to what was actually put together and what was actually, accessed, in order for audit organizations within a company to be able to verify and be able to ensure that things are being properly implemented. It's not all about let's implement data security process within the organization. It's also ensuring that that process is being followed in order to prevent any potential breaches of sensitive information. So if we want to kind of summarize to some degree how we want to be able to define the data security and access, the first thing to think about is, what is it that I am trying to protect? Am I trying to protect a field of information, like a social security number? Am I trying to protect a record of information? Maybe I have a record in the database that has multiple fields of information, like my name, my address, my city, my payment card numbers. I have multiple pieces of information. I may want to protect certain fields within that data record. Or it could be, for example, if, I've noticed nowadays a lot of times when you register for a certain, for certain programs, or you register, for example, for a doctor's appointment, rather than you showing up at the doctor's office and providing your ID in order to identify yourself, they're asking you to provide that information electronically. So you provide them an image in order to be able to, for them to know who you are and what you look like before you get there. So in some cases, it may be that I need to be able to protect images or a passport, for example. So sometimes it's not just, a field of data or record of data. It could be a file of information. It could be an image. So what is it that I am trying to protect is the first thing to identify. Then we can decide, well, how do we want to protect that piece of information? If I'm protecting an image, probably encryption is the best way to be able to do it. If I'm protecting a payment card number to comply with PCI DSS, for example, tokenization may be the right mechanism to utilize. We have to also then think about, from an encryption perspective, what type of an algorithm makes best sense. Most of the time nowadays, everybody's using AES 256, the strongest that we know for now. And therefore, that's what a lot of the protection requires. But it also depends on what other use cases are there, whether other algorithms make better sense. And whether I'm using, tokenization, it could be that I'm using, methods of protecting the data that are format preserving, meaning, or even applies for encryption, that when I secure the data, if I'm securing, digits, I want that token to also be digits. If I'm encrypting something that is alpha, then I want to make sure that my secure data also is alpha and is also of the same size that I had originally. A lot of times with encryption, it's not possible, depending on the algorithm you're utilizing, in order to be able to make sure that the encrypted data is the same size as the original data. So format preservation is a way of being able to achieve that. And that way, databases that are used to receiving a field of a certain size can continue working with fields of that size, so that security is not impacting the rest of the organization or the rest of the systems that are in place. And as I mentioned previously, it's not all about the securing of the data. It's also about determining what applications or what users are actually authorized to access that data, and to what degree they can actually access that data. Can they see all of it, or can they only see part of it? Do they really have a need to see all of it? We should only provide access for what an application needs for its particular use case, rather than providing everything and letting the application decide what it is that it wants to be able to utilize. And being able to implement masking, whether it's masking certain parts of a field, as we're looking at a couple of examples, or whether it could be that I may want to redact certain data. Perhaps there is information that an application doesn't need to have. They don't need to know what my address is, and therefore there is no need to provide them my address if they have no need for it. So data masking and redaction are, again, techniques that can be useful for protection. It's not just about protecting the data while it's stored or travels around the company. It's also being able to only provide what is needed for an application in order to reduce risk. Now, if we think about these data protection techniques and we abstract them from the application in order to be able to offer some centralized method of protecting information, then it becomes a lot easier. If we look at all the different applications that we show, all the different circles that we show that could be in an organization, we can define some sort of a data security platform. That is the central server or central data protection engine. If we have that defined, then an application would only have to call that data security platform, provide the name of the policy that says how does this data need to get protected or how this data needs to be unprotected, and just ask that data security platform to secure or unsecure that data. So the benefit of abstracting all of the security information from an application means that now we have a centralized method of defining how information needs to be protected. And it's not defined by the developer or by a programmer in a sense. It can be defined by someone responsible for data security in the organization, who defines the policies, defines what data needs to be protected, defines what permissions are needed, what applications need what type of data, defines what algorithms, what keys, what rotation may exist. That can now all be centralized rather than sitting out in every single application. And that was the challenge with the SDKs, is that you had to figure out how to coordinate all that information with all the applications that needed that data security. If we bring all that together into a data security platform where we can actually define the policies and have the right persons define those policies, then we have a much better method of centrally managing the security and ensuring that it is applied the way it should be applied by all the different applications. Because it is not up to the applications to define all that. That is all now part of the centralized policy within the data security platform. And therefore, with that in place, you can actually secure any type of data from any type of application and any type of environment without having to share all that information with all those different application providers, all those different developers that are working on those applications. So now let's take a look at a couple of examples of how this would function and some of the ways of being able to apply this application level data protection. Now, in this first example, we're looking at protecting fields. And again, the intent here is that I want to protect that field of information. In this case, it could be a payment card number before it is stored or sent anywhere. So if we're thinking about a web merchant, when, uh, when I, as a consumer, enter my information for, paying for something, at that point in time, as I mentioned, that web server or that application wants to immediately protect that piece of information before it does anything with it. The way that I would do that is it would actually make a call to that data security platform to say, please protect this information for me using this policy. And the application gets back that information protected. Now, the application has no idea, and the developer has no idea whether that information was encrypted, was tokenized, what algorithm was used, keys was used. It's not important for the application. All the application needed to know was to call that data security platform, and with the data and the policy to protect that data, the data security platform secured it and provided back to the application. Now the application, my payment card number that I submitted is now protected. Now that application can go ahead and store that information in the database or wherever in the organization may be needed. And now it ends up that the data at rest is already protected before it even got into the database, so that it is all secure within the organization. Now, when we take a look at it, it's also, as I mentioned, there are applications that actually need to use that data, need to use those payment card numbers, maybe to process a transaction, or maybe they need it in order to validate a customer with the last 4 digits, for example. So it is now important for that application, the policy that was defined in the data security platform, to decide what is needed for that application. What part of that data does that application need? So if the application now needs to be able to retrieve that information from a database, it would actually retrieve that information, but it is secured. It's encrypted. The application cannot understand it. The application can then make, again, a call to the data security platform with the secure data, with the name of the policy, and the data security platform will provide only the information that that application actually needs to see. And we can see that in this case, it can see the first 4 digits of a card number potentially, and the last 4 digits. Maybe it cannot see the middle digits of it. There is no need for this application, based on its use case, to see all of the payment card number. It only needs to see portions of that payment card number, and that's all that they get to see. Now, if we take a look at this similar concept, but applying it, as I mentioned at the beginning, this could be now a record. And again, for a record, that data security platform can have a policy that says only protect certain fields of that, of that record. In this case, you can see that I've highlighted like the first and last name of an individual. We see the address for that individual, and we see perhaps their social security number. And someone in the organization has determined that the name and the social security number are the important pieces of information, the sensitive pieces of information that need to be protected. So they have defined the data security policy or the policy within the data security platform to protect those fields. So if that application now calls the data security platform, we can see that those fields are the ones that are protected. And you see that in this case, where format preserving encryption comes into play, that I am receiving an encrypted first and last name that are of the same size as the original first name and last name, the size of those fields. You can see that it was selected that I want to be able to use an alphanumeric set of characters for the resulting encrypted data. And that's why we see that we have numbers and we have some letters, upper and lowercase, depending on how the algorithm worked in order to protect that information. We also see that the social security number was also protected. And we can see that in this particular case that the formatting of it, the little dashes, it was 3 digits, 2 digits, and then 4 digits. The dashes are preserved so that the format is not modified. We're securing the data, but we're not modifying the format of that field. And again, it has the same size as the original field that was provided. Now that application has the information protected, and it can actually go ahead and store that information in a database or wherever it's needed, similar to what we saw for protecting fields of information. Likewise, when we think about unprotecting this information, if we have an application that needs to have access to that individual's information, again, a policy can be defined in the data security platform to only reveal what that particular application requires. So when that application actually reads a record from that database, let's say, and those fields are protected, it can actually now call the data security platform to unsecure it based on the policy that it provided. And we can see that in this case, the policy that was defined by someone in the security organization is that application can actually see the first letter of the first name, the first 3 letters of the last name. They have no need to actually see the physical street address of that individual. They can see the city, they can see the state. And again, for the social security number, they may only need to see the last 4 digits of that social security number. A different application may have access to the entire social security number, perhaps to the entire name of the individual. So you can actually define different policies for different applications. So the applications will only see what they're actually entitled to see or what they actually need to see. And that is the benefits of first centralizing all that information, because if there is some need from a security perspective or some change in policy, and some changes want to be made that say, okay, no, we really want to now encrypt the addresses as well. Well, you only have to go to the data security platform, modify the policy in order to protect the additional information. And if for some reason there is a need to change what an application can see, you would only have to go to that data security platform, change the policy for what a particular application can actually see. It's all part of the same policy. It's just that different applications can be defined with different permissions to access different types of data. So I don't need to have developers in every application have to modify what they have to see and make sure that they properly implement it. I have a central place where I can make sure that the right policies are defined. The applications have no control as to what those policies have. All they need to know is this is the name of the policy that I use to secure data or to unsecure data. And it may be that certain applications are only allowed to secure data. Other applications may be allowed to only unsecure data, and others may be allowed both. Those are all things can be defined centrally within that data security platform. So with that, just wanted to tell you a little bit about prime factors. We've been around over 40 years. We actually work in 2 different sectors. We develop software applications for both securing data, the example that we talked about or covered in this presentation, and we also work in securing payment security, whether you're dealing with processing payment transactions or issuing payment cards. We also work in that space from a security perspective. The product that we promote for data security is our Encryption product, as you can see on the right side of the slide. And we focus on application level data protection. And as I covered on the slides, the concept is, a simplified way of being able to secure data. So the methods, the schemes, and everything that I talked about how data can be secured and how it should be secured are the type of things that Encryption can do. Just a piece of what Encryption can do. I wanted to mainly focus on, why is it that we need to reassess how we're securing data, what it is that we really need to be protect, and how we can actually simplify it with some of the technologies that are out there today. And the entire concept of being able to centralize how data is being protected rather than leaving that up to application providers not only provides a higher level of security, but a much simpler way of being able to manage security within an entire organization. A little bit about the Encryption product. we promote that we can actually deliver security in as little as 3 lines of code, because it is as simple as I mentioned in the slides. It is about, here is the data that I want to protect. Here is the information that I actually, the policy that wants to be utilized, and please secure or unsecure that data. You can see in the product, we have everything from a user administration perspective to define those data protection policies, define those access and permissions, everything having to do with the key management, and that audit login and reporting that are so important in order to ensure that security is being applied how it should be, and to the applications that it should be. We have different ways within the product that one can access a product through an API library or through a command line, and different techniques to be able to secure that data, whether that happens to be encryption or tokenization or applying data masking. Those are all the controls that can be defined within that data protection policy. So, the benefits is a way of being able to automate that data protection, not having to do it at the applications, do it in a data security platform type of solution, abstracting everything having to do with that security from the applications. And by protecting the data at the application layer, we know that that information is now secure regardless of where I store it or regardless of where I send it. That information is secure. It's about data-centric security. And EncryptWrite is really very simple to deploy. There is no cryptographic expertise or any professional service really needed in order to be able to deploy the solution. It's a very simple solution to deploy. So in summary, I think we saw from the reports, both from Gartner and from the Thales Data Threat Report, that the threat situation has not decreased. We are, in a sense, forced by technology to be able to have an environment that is not controlled by a particular perimeter. It's everywhere. So it's a much more complex deployment environment that we have to live with today. The hackers are taking advantage of being able to, create malware, be able to get into applications, be able to deploy ways of being able to siphon sensitive data, and therefore is something that we still have to keep an eye on. We still have to monitor ongoing within an organization to make sure that we're deploying the right type of solution and ensuring that what we have deployed is working the way that it should. It was fascinating in the Thales report about a lot of the organizations that, surprisingly, were having issues with security audits that were the ones that had the more, the higher number of, breaches. And we also have to keep in mind that, sometimes depending on how things are deployed, human error is something else that we have to deal with. So the more that we can automate or centralize or, remove the human factor to a degree from security, the better off some of the solutions can be. Within organizations, as I also mentioned, we do need to take a look at where are those security gaps. Am I protecting data as soon as I receive it? What am I doing with that data before I secure it? How is that information being received? Hopefully it's being received over a secure channel. So it's analyzing any piece of sensitive data. How do I receive it? How do I provide it? What are all the different stages that it go through in order to ensure that we can identify those security gaps? And from an organization, taking a look at that, data-centric security approach. It's not about, let me make sure that the door is locked to the room. Today, that room is very difficult to lock. It's the entire world and all the data centers that we have deployed everywhere. And therefore, if we change our approach to realizing, let me focus on protecting the data. It's good to lock the doors. It's good to lock the windows. But let me make sure that the data or the sensitive information that I have is protected and not just rely on the perimeter. So having those multiple levels of security is also important. And hopefully one of the things you picked up on during the presentation is that application level data protection does not have to be hard. Being able to have to deploy things in SDKs within applications is very hard, but that is not how it has to be done. There are ways, simple ways of being able to abstract all that security, to a data security platform in order to define policies for how to protect that data. So when we're talking about application level, yes, you have to touch the application to some degree to now take out all that crypto perhaps that you had and now be able to simply call a data security platform to protect that information. So it does not really have to be hard. It can actually provide stronger security and more control over what you have in an organization by centralizing that security environment. And as always, encryption consulting and prime factors, we've been working in these sectors of trying to help customers, whether from analysis of what they have internally to providing some solutions to be able to address those problems. The companies have the expertise in order to be able to help you secure and navigate the challenging world of data security with the ever increasing threats that we see out in the environment. So with that, you have here our link to prime factors as well as my contact information. I know we're going to also be getting into a QA session later, but I wanted to make sure you had all the information for a company and for myself. So thank you for listening in. Hopefully you learned something in the process and we can help you. And now I can get back to the ski resort behind me. Thank you.
Thank you, Jose. You shared some really important points. Now let's get into the audience question and answer session. Everybody feel free to type them in the Q&A panel below. So starting off with the first question, how can organizations best address the challenges of protecting data at the application layer?
An interesting question and a complex question in a sense, because part of the challenge is trying to understand the specific requirements based on regulations or security policies that may exist with an organization or privacy laws, for example. And then it's also a challenge of trying to be able to identify the data. What is the data that is impacted or that falls under some of those regulations or privacy policies? Where is it located? How can we actually go ahead and protect it in the best manner possible, as we discussed during the slides. I believe there should be a white paper that we attach from Prime Factors that talks a little bit about, how you can actually go through that process and analyze it from that perspective.
Okay, moving on to the next question. Why is crypto agility becoming such an important capability, and how is it supported when creating the data protection policies you described?
Great as well. And I think that's a very important topic and something that gets a lot of press these days about crypto agility. And the challenges that we have seen over the years, years ago, Triple DES was sort of the standard for protecting data. AES became the new standard many years ago as well, but it is an evolving situation. And it's not just the algorithm, but sometimes the keys that are used and what is the strength of the keys that are used. So one of the challenges with crypto agility is how do you actually keep up with the standards? And if you're deploying or implementing security at the within the application using crypto toolkits and so on, it's much more complicated to be able to keep up with those standards because you're going to have to modify the programs and modify how things are being done or change how keys are being handled. And the advantage of data security platform is that by centralizing or abstracting those security requirements and policies that as we discussed from the applications themselves, it makes it easier because you can just modify those policies to use a newer method of algorithm or protect it in a different fashion. As I kind of mentioned towards the end, that it's very easy to go in and modify the data protection policy based on additional fields that need to be protected, or based on I need different algorithms, I need different key sizes in order to protect it. So I think that's one of the important aspects that gets simplified by being able to abstract in the policies Now you have a central place in order to be able to perform that instead of having to do it within applications, specifically using crypto toolkits.
Okay. Now moving to the next question that we have. How do you scale the data-centric security concept described across large deployments?
That can be a challenge, and unfortunately, it really depends on the specific environment or the requirements. So, if we're talking about a single application servers, or maybe there's a handful of application servers, are they all in a single location? Are they in multiple locations, around the world? Um, and in some cases, you also have to consider some of the performance requirements. It may be easy to be able to say is I only have a single application that I need to protect files or images. And in that case, it is easy to put the data security platform on that same server in order to be able to protect the data locally. If you're dealing with multiple servers at a location, then it is possible to perhaps say that I'm tokenizing data, let's say, and I may need to be able to tokenize or detokenize data from multiple applications that are residing in multiple servers in one location or many locations. And in those cases, it may be easier to have a sort of a centralized data security platform that is performing the tokenization and detokenization. So you can implement calls using web API, like a REST interface, for example, so that any of those applications and servers can actually make those calls to that centralized server to tokenize or detokenize data or encrypt or decrypt data. That makes it a lot more flexible. And then it really depends on if you're dealing with multiple locations around the world. Do you want to be able to have multiple, these centralized servers in order to secure data in those different locations? And if you're dealing with a large load, then it may be possible to put a load balancer, for example, in front of those data security platform servers in order to be able to balance the load or distribute the load among different servers. So there's a lot of flexibility with the product from a deployment perspective, where you can have either smaller deployments that are more embedded, if you will, with the applications and having the security within it, or completely abstracting it and be able to have servers from all over the place to be able to call those centralized servers for tokenization. So it is fairly simple and a lot easier than having to deal with modifying the applications to perform that task.
Great. So we do have another question from the audience, which is given the rise of Gen AI, how should we rethink data protection strategies for sensitive information, considering these technologies can generate or potentially expose data that was never directly accessible to traditional security systems?
Dealing with AI is going to be challenging, and as I mentioned, it's not just AI that we utilize, but again, AI that can be used externally to be able to extract the data. And I think one of the hardest things for organization is to be able to identify where do I have the sensitive data, and particularly if we're coming up with new pieces of information that we're storing, how are we storing it? And things can change, where things that at one point in time were not considered sensitive, that maybe are now considered sensitive. So I think one of the hardest things for organization is being able to identify where is all of that data. AI may be able to help you identify where all the data is at, in order to then be able to figure out how to protect it. And I think when I look at AI, most of the time, it's something that can help in order to be able to perform certain tasks or be able to automate certain functions. And one of the potential uses is, let's go try to see if it can help us in order to be able to identify the data and things that are sensitive in a flexible manner, so that I can use AI to say is, now I'm considering zip codes to be important, and how do I identify those in order to bring them in. So I think there's a lot of things in AI that we haven't quite uncovered all of the uses for it, both from a good perspective and from a bad perspective. And I think as the technology evolves and as we start seeing different use cases and applications for it, then we'll be able to address it and be able to leverage it a little bit better for protection purposes rather than for attack purposes.
That was incredible, Jose. So those were all the questions that we've had. Thank you so much, Jose, for joining in. And for anybody who wants to learn more about the topic, we do have some attachments that you can download and you can learn more about the topic that Jose has shared. If you have more questions, feel free to reach out to us or Jose, and we will be happy to help you. Thank you so much, Jose, for joining us. And we do have more sessions on the way, so please stay tuned.
All right. Thank you very much.